Hello and welcome to Brian's Biology. Today we're looking at biochemistry part 2. In the previous part we looked at atoms and how they were the main players, the main characters in the story of life, or at least in the story of the biochemistry. We talked about how in any great story you begin with introducing the characters and then you work on the relationships. Today it's time to look at the relationships between our characters, the atoms. And the relationships are bonds, okay? So today's lesson, bonds. We've got 3 objectives. Our first objective is going to be describing the difference between inter and intramolecular bonds. It's very, very important to categorize bonds accordingly. Okay. Our second objective today is to explain the 4 main types of commonly found biological bonds. These are the bonds that are most prevalent and most important in biological molecules. They're going to tell us an awful lot about how life proceeds. And our third objective will be to assign properties to molecules based on the kinds of bonds they have within them and between them. Okay, that's a very valuable skill. Now for today's lesson, we're also going to be looking at a concept called SPF. What SPF stands for is structure, property, function. And it's this pervasive idea in biology that the functioning of something depends upon its properties and its properties depend upon its structure. Let's look at an example of that. So human hands. Okay, what is the function of human hands? Well, of course, everybody knows human hands are there so that we can pick up, so that we can do things like grabbing, holding, and manipulating objects. Okay, these are the functions of our hands. What are the properties of our hands that allow us to do that? Well, the properties are that they are flexible and they are movable. Okay, and by being able to flex and move my fingers and my hands, I'm able to grab things. So here we see how the property relates to the function. What about the structure? What gives our hands these properties? And the answer is, well, it's the joints and the muscles, how it's put together. So the joints and the muscles are the structures of the hands. That leads to the property of them being flexible and movable, and that leads to the functioning of being used to make some weird hand movements like I'm doing now. Hopefully you get the idea. Now we actually had a little bit of that in the previous lesson when we talked about the structures and properties and functions of carbon, if you remember, as an example. Carbon, the structure, was that it has an atomic number of 6, meaning 2 electrons in the first shell and 4 valent electrons in the second shell. That was important because that means it's very versatile. Anything with 4 valent electrons is able to either gain, lose 1, 2, 3, or 4 electrons, meaning it can react with many other kinds of atoms. We called it a versatile reactor. Okay, now that's its property. And what function does that give? Well, that means that we can build these big complex molecules based on carbon skeletons. That's why we're called a carbon-based life form. So this idea of structure, property, functions pervasive throughout biology from the atomic level up until the macro level when we're talking about human hands. And it again applies to today's lessons. The structures of these bonds give us some properties. These properties on the molecules with those bonds lead to the functioning of these biological molecules. So although it may not seem like that today in today's lesson, it's extremely important that we're able to get the properties of molecules based on the kind of bonds that they have. So without further ado, let's look at objective number 1. And that is knowing the difference and being able to categorize bonds between inter and intramolecular bonds. Well, we got to break down those words a little bit, so let's go ahead and do that. The first word we're going to look at is the word intra. And what intra means within. Okay? So this basically means bonds within molecules, bonds that are actually holding the atoms together in the molecule. Okay? And that's not to be confused with inter. Intermolecular bonds means bonds between molecules. So what holds a single molecule together, and we know that a molecule is a collection of atoms, is an intramolecular bond. And then what might hold 2 molecules together would be an intermolecular bond. Okay. Now in today's lesson we're going to see 2 examples of intramolecular bonds, and those 2 examples are ionic bonds and covalent bonds. Okay. And for intermolecular bonds we also have 2 examples, and they are hydrogen bonds and van der Waals interactions. Okay. Sorry, that should be 2 A's there. So that gives us the 4. If you want to skip ahead a little bit and just very briefly mention Objective number 2. Well, objective 2 says there are 4 main kinds of bonds, and here they are: ionic, covalent, hydrogen, and van der Waals. Okay, and these are subdivided down into intra and inter. So ionic and covalent bonds are the bonds we find inside a molecule, holding those atoms together. Whereas the intermolecular bonds, hydrogen and van der Waals, are 2 examples we concentrate on in biology. These are bonds that form between molecules. Okay, so that's the difference between inter and intramolecular bonds. Now let's look at our first example of an intramolecular bond, and that's going to be ionic bonds. These are the most powerful, strongest bonds we find inside molecules. Okay, now an ionic bond, well, let's look at the word ionic. Ionic obviously means in relation to ions, and you may already know that ions are charged atoms. So if you remember from the previous lesson, an atom has a charge when it has a difference between the number of protons and the number of electrons. The question is, how does that help us to form an ionic bond? Let's look at a specific example. Ionic bonds usually form between metals and nonmetals, and our example we're going to look at is sodium chloride, or common table salt, a molecule that isn't an organic molecule but yet plays a big role in life. Okay, and in order to draw this bond, we'll have to know the atomic numbers of each of these atoms. The atomic number of sodium is 11, and the atomic number of chlorine is 17. Okay, now let's go ahead and draw our sodium. So first of all, we'll draw a nucleus, and of course we know that the protons and neutrons would be concentrated inside of that. Around that, we're going to have our n is equal to 1 orbital, and we're going to put 2 electrons, because that's how many fits in there of the 11. And then we're going to put 8 in the second shell. 1, 2, 3, 4, 5, 6, 7, and 8. And that leaves us with a valent electron of 1. Okay, so sodium, a bit like hydrogen, is desperate to react, okay, because it's very close to having that full or empty electron shell. What about chlorine? Well, chlorine, 17 protons and neutrons inside the nucleus. In the n is equal to 1 orbital, we have 2 electrons. In the n is equal to 2, we have 8. 1, 2, 3, 4, 5, 6, 7, and let's squeeze another one in there, 8. And then that means in the third n is equal to 3 orbital, which can hold a maximum of 8, we have the remaining 7. 1, 2, 3, 4, 5, 6, 7. Well, if you have 2 atoms, one which desperately wants to lose an electron so that it can have an empty shell, and one that desperately wants to gain one so it can have a full shell, well, there's an obvious solution staring us right in the face, and that would be 1 electron to move from sodium to chlorine. So chlorine, having the higher electronegativity, is going to take the electron away from sodium. Now, if we take an electron away from sodium, that would mean it would have a minus charge. Okay, losing an electron, I beg your pardon, gives you a positive charge. My bad. Electron jumps across, it would have a positive charge. Chlorine, on the other hand, has just taken on the extra electron, so it's going to have a negative charge, meaning it has 1 less protons than electrons. Having more electrons than protons means a negative charge. Okay, so we have this electron jumping from one to the next, leaving behind a positive ion, which we call a cation. And we have the electron jumping over here to chlorine, giving us a negative, which means we have an anion. Okay, and it's the attraction between this anion and this cation that is forming the ionic bond. So in any molecule with ionic bonds, we have a metal and a non-metal. We have electrons jumping from one atom to the other, creating a positive cation and a negative anion, and the force of attraction between the two is called an ionic bond. Okay? All right, now let's look at the second kind of bond.